Okay, I want to go through this section on Reynolds number, and this one is for non-Newtonian fluids, so I'm going to focus on this one right here. And you probably know a bunch about the Reynolds number already, but I'll just mention that it's often thought of as a ratio between the inertial forces and the viscous forces. And what I want to point out is the Reynolds number is what's called a situational parameter. And this is situational, depending on the situation, versus a material parameter. So a material parameter would be something like, density. And this is in fact, viscosity is a material parameter. The dynamic viscosity and the kinematic viscosity, these are material parameters. But the Reynolds number is a situational parameter because you can see it depends on the situation, which involves a velocity of the flow, that's the V term, and then it also involves the diameter of the pipe or some characteristic length, which is, if it's not a pipe, this will be turned out to be the hydraulic diameter. And that is later on in your the FE materials. Okay, so we've got that this is a situational parameter, and so it depends on the situation, the velocity, the diameter, the geometry, which is in the diameter, and then the material parameters of kinematic viscosity. So let me just rewrite this term over here. The Reynolds number is equal to V times D, velocity times the characteristic length, I'm going to write diameter here, divided by the kinematic viscosity. Here's the term. And it's the same thing as a ratio of inertial forces to viscous forces. And we see down here that when the viscous forces are greater than the inertial forces, we get slow flow. So, and that's the condition here where the Reynolds number is less than roughly 2100. It's characteristic of laminar flow. This is slow, even flow. And when you get turbulent flow in the case of the Reynolds number exceeding 10,000, and that is when the inertial forces represented by the velocity, really, velocity is the big term, those dominate the viscous forces, and you get turbulent flow. Oh wow, turbulent. Okay, and then in between these numbers, 2100 and 10,000 is kind of a transition region, but oftentimes 2300 is used as the mark between the Reynolds number. Notice it's dimensionless, as the transition from laminar to turbulent flow.